You see it every day in the gym. Plates rattling, people straining under massive loads. But beneath the skin, muscle fibers and tendons are often subjected to an invisible tearing, struggling against tension they weren't positioned to handle. Chronic joint and muscle injuries rarely stem from the weight on the bar alone. Most damage occurs when the lifter operates their skeleton outside of its natural structural limits. Your body is governed by a specific mechanical user manual, written in the laws of physics. Learning these biomechanical principles is a prerequisite for any training program intended to be both safe and effective. Mastering these physical laws prevents the slow accumulation of joint wear that eventually ends an athletic career. For holistic techniques on exercise, food, and lifestyle, subscribe to 369 Somready Success. The human musculoskeletal system is a literal mechanical engineering project. It functions through a sophisticated network of biological cables and pulleys designed to generate force against the external world. This diagram shows the forearm as a lever. With the elbow as the fulcrum, the bicep generates force to move weight. Attaching close to the joint creates a mechanical disadvantage. The math proves muscle force must be 8 times greater than the weight lifted. A muscle never just moves a weight independently. It is a force-generating cable entirely dependent on the geometry of the skeleton it is pulling against. This graph tracks knee torque. Force generation drops significantly at the movement's extreme ends, making the system vulnerable. Losing leverage in these drop-off zones means muscles can no longer shield the joint, transferring thousands of pounds of force directly into cartilage and connective tissues. This 3D surface plot illustrates the force-velocity relationship. It shows that as the speed of a muscle contraction increases, its ability to sustain force decreases. High speed combined with poor joint angles creates a high-risk zone for structural failure. Joint blowouts and ligament tears are the predictable result of combining these poor leverage points with excessive speed. They are mechanical failures, not random accidents. Gym culture is generally split between 2 methods: isolating single muscles for aesthetic size, or training multi-joint movement patterns for functional power. Isolation training targets the specific muscles surrounding a single fulcrum. Increasing the cross-sectional area of these muscles provides a denser structural support for the joint, helping it withstand the high internal torque demands identified in the lever studies. Compound movements take those isolated muscles and teach them to fire as a unified system. This distributes the load across multiple levers, ensuring that no single joint is forced to bear the entire weight alone. Relying on only one approach leaves the body either uncoordinated or structurally weak. Longevity requires a balance of both isolated stability and integrated movement. Modern military forces utilize a hybrid tactical athlete model to survive extreme physical loads. It is a practical application of biomechanical laws to protect the body during high-intensity tasks. Applying these principles changes a training program from a series of random exercises into a predictable method for building a body that is both structurally dense and neurologically efficient. This shift in perspective turns the gym into a controlled environment for maintaining physical capability throughout your life. Fitness is a collective journey. Join the Mask community across the world to help create health, wealth, and happiness for each other. Share this video with as many people as possible so everyone can lift with precision and avoid the mistakes of the past.